Hey guys, it's Mrs. Villette, and in this video we're going to start to discover some of the properties of logarithms. These are very similar to exponent rules. They are a set of shortcut rules that we can use to simplify anytime we have logarithmic expressions in an equation or a problem. So let's take a look at this first problem. We have the log base 2 of 2 to the 5th times 2 to the 4th. The first thing I'm going to do is follow order of operations, which says do whatever is inside the parentheses first. So I have log base 2. Since I am multiplying two things that have the same base, the exponent rule is to add their exponents. So this would be log base 2 of 2 to the 9th. Now this expression is saying 2 to the what equals 2 to the 9th. So 2 to what power equals 2 to the 9th? Well, the exponent is just staring right at me. This is one of our cancellation properties, so the answer to this problem is just 9. Now similarly, a related problem is just log base 2 of 2 to the 5th. I can see very easily by the cancellation properties that the answer is just the exponent of 5. And similarly on this problem, the answer is just the exponent, or 4. So the next part of the worksheet asks us, how are these expressions related? So I have these two expressions and they are somehow related. So I want you to think about the results. 9 was our first answer versus 5 and 4. I think you can easily see that 9 equals 5 plus 4. So my conjecture on the rule is that if I have the log of two things multiplied together, like I did over here in the first part of the problem, then I can break that log apart and do log of m plus log of n. So keeping in mind that in our problem that this 9 over here was the log base 2 of 2 to the 5th times 2 to the 4th, and that this 5 was log base 2 of 2 to the 5th, and this 4 was from the log base 2 of 2 to the 4th. So basically what we've just said is log base 2 of 2 to the 5th times 2 to the 4th is the same as log base 2 of 2 to the 5th plus log base 2 of 2 to the 4th. So notice that multiplication symbol on the left expanded to an addition sign on the right. And that's really just based on exponent rules. When I multiply things with the same base, I add their exponents. Logarithms are just asking for the exponent, so notice this is an answer of 5, or just the exponent, an answer of 4, or just the exponent, and I have added them. Okay, let's try to look at the next problem, which ties us to another type of rule for exponent rules. So in the next example, the first expression we have is log base 3 of 3 to the 8th over 3 squared. Very similarly to the last problem, we will simplify inside the exponent first. So the rule here is when I divide two exponents with the same base, I subtract their exponents. So this gives me log base 3 of 3 to the 6th, or more simply, just 6. My first expression down below it is just log base 3 of 3 to the 8th, which is 8, and log base 3 of 3 squared, which is 2. So thinking about how these expressions relate to each other, we're saying log base 3 of 3 to the 8th over 3 squared versus log base 3 of 3 to the 8th and log base 3 of 3 squared. So this first answer worked out to be 6. This worked out to be 8 and 2. So I believe the proper relationship is that 6 equals 8 subtract 2. So we can actually change this and say that the log base 3 of 3 to the 8th over 3 squared equals the log base 3 of 3 to the 8th subtract the log base 3 of 3 squared. So that's my conjecture over here. If I have a log base b of things divided, then the answer to simplify or expand will be to subtract the logarithms of each of those things. And again, this is just based on the exponent rule. If I divide things with the same base, I subtract their exponents. Remember that logarithms are just exponents. Okay, our last set of problems has to do with things where the base does not match the expression that is in the parentheses. So log base 4 of 3 to the 5th, that's something I have to evaluate on my calculator. And in order to evaluate that in my calculator, I am going to do log 3 to the 5th, comma 4, if I have a new calculator. Or on older calculators, I will do log of 3 to the 5th divided by log of 4. So the answer that I get is approximately 3.9624. The second expression I am asked to evaluate is 5 times log base 4 of 3. So in my calculator, I'm doing 5 times log of 3, comma 4, or on the older calculators, 5 log of 3 divided by log of 4. So on the calculators, the value of the base is always the second part in your syntax, so it's what goes after the comma, or it's what ends up being divided. And strangely enough, in my calculator, I get the same exact answer of 3.9624 approximately. So I believe the relationship that I'm seeing is that the log base 4 of 3 to the 5th is the same thing as 5 multiplied by the log base 4 of 3. So try to figure out what's happened there between the two expressions. They both have a log base 4. They both have a 3 somehow involved, but the 5 ended up in different places. I'm going to let you fill in the conjecture on this last one, what you think the formula is. So what does log base b of x to the r simplify to? Notice that the value of the base on the logarithm is different than the value of the base on the input of the logarithm. Okay, on the next slide, I'm going to choose one of these two conjectures that we've come up with to prove. So I am going to prove this first one, log base b of m times n is log base m plus log base n. So here we are, we're going to prove this first conjecture, which is basically related to the product rule for exponents. So the log base b of m times n is equal to the log base b of m plus the log base b of n. So to prove one of these conjectures, we need to start with one side and make it look like the other side. I'm going to start by letting log base b of m equal some value x, and log base b of n equal some other value y. So I'm just letting this